that you have a few jobs and they have a few difficulties and you have a specific days, so you just have to do one thing. Prime thing is that you have to finish at least one task every day, right? So you have 2 days, so basically these are the 6 tasks you have, and one task you have to finish every day. So I have to bifurcate these 6 tasks into 2 days. So I can just say, okay, the first 2 tasks I'll do in first day, one day, and the remaining 4 tasks I'll do in the next day. This is how I can bifurcate my task. Now what after doing this bifurcation, it just says that we have to return the minimum difficulty of a job schedule. Now what this minimum difficulty is defined as, the difficulty is defined as the sum of the difficulties of each day of the days, and the difficulty for one day will be the maximum difficulty for a job done on that day. So as you saw that I bifurcated into this 2 halves, which is the 6-5 and the 4-3-2-1. So for the day 1 I bifurcated into 6-5, so its difficulty will be 6. For the day 2 I bifurcated into 4-3-2-1, its difficulty will be 4, which is the maximum difficulty for that specific day, and that I should add in my answer. So I should give my answer as 6 plus 4, which is 10. But you will see, bhaiya, answer is not 10. Yeah, because we wanted the minimum difficulty of a job schedule. So we have to figure out what will be that chance which will give us the minimum difficulty. And also, if you cannot find a schedule such that you have to finish at least one task each day, then you have to return a -1. So it is very obvious. The -1 case, it's very obvious that if you have days as 4 and the tasks are only 3, so one day will actually, you will be empty, but you don't, or like you cannot be empty. That's the reason. If your n, which is the number of tasks or number of jobs you had, if it is less than your number of days, then for sure for some days you will be empty. Thus you have to return a -1. So okay, -1 case is done. Let's come back and see what all cases we could have had. So if I just take the same example, then as I said, it's a bar which we are placing just to say, okay, I bifurcated some tasks for this day 1, then day 2, and then so on and so forth. So I just had a bar just to bifurcate. Okay, the left part for the day as 1, next part for the day as 2. So I just bifurcated here, saying that the left part for the day 1, right part for the day 2. Here I bifurcated left part for the day 1, right part for the day 2. So if I just bifurcated, maximum is 6, maximum is 5, so answer will be 6 plus 5, which is 11. But still we wanted minimum job scheduling, our cost, or like basically minimum of this difficulty of our job scheduling, which is here is it's 11. Maybe we can reduce it. If I bifurcate at this point, it will be 5 plus 4, it is 10. Bifurcate at this point, it will be 4 plus it will be 6 plus 3, actually 9. Bifurcate at this point, it will be 6 plus 2, it is actually 8. If I do at this point, then I will say 6 plus 1, which is actually 7. Now you might ask, bhaiya, what about why you did not do a bifurcation in the end? Bro, if I did, then for sure, like, which means, okay, for one of the days, all these tasks, for the other day nothing, but nothing you cannot do. You have to do one task every day. So please make sure that you do one task every day. So the last bifurcation should be at this point. And also it is the minimum difficulty which we can achieve, which is 7. And that's the reason you saw the answer was 7. Cool. Now coming on back is just placing a bars, right? So the normal brute force solution is you had some of the tasks or some of the jobs, you just have to place some bars. So in this example, let's say we had 6 balls and like k equal to 3 bars, or basically k equal to 3 partitions I have to make. So I know I have to place in 2 bars. It's just a standard PNC formula which we have, that is n minus 1 c k minus 1. Just saying, if I have these as my balls, which is 6 balls, and I have to place k bars, or basically separate them into k partitions, then the formula is n minus 1 c k minus 1. And it's just to showcase that, again, PNC is not required at all in this question. It's just to showcase that your time complexity will actually be n minus 1 c k minus 1 multiplied by n. Bhaiya, why n? Because you will have to grab the maximum number also. You will have to, okay, you can make all these possible number of ways to partition. Like you can just make all these possible number of ways to partition, but still to find for one specific group the maximum element, you will take again O of n time. So time will be O of n minus 1 c k minus 1 multiplied by n. Now Again, you don't have to go into very deep. It's just to showcase that this is actually a factorial. This is a factorial. So your value will be actually in factorial, which is very high. So brute force will not work. It's just that we have to show to the interviewer that okay, brute force will not work. Then we will go on and try to optimize. Optimizing is just recapping of what we had seen previously. So if we go back and see, we are at the first place, which is 6, 5, 4, 3, 2, 1. So we are at 6 now. To take for the first day, if you go back and remember, to take for the first day, either you took 6, or you took 6, 5, or you took 6, 5, 4, or you took 6, 5, 4, 3, and so on and so forth. Exact same thing I did. Either I took a 6, or I took a 6, 5, or I took a 6, 5, 4, or I took a 6, 5, 4, 3, or I took a 6, 5, 4, 3, 2. Okay, great. But bhaiya, that is all the options you tried. But it is just saying, okay, it is for the first day. Again, I am saying I have D days to cover. It is for the first day I am trying all these options. Again, the problem will boil down to, okay, then you are starting with this new index, which is j plus 1, because if the j was here, as you saw, okay, I is here, j is here. I is my this point itself, but j I'm just saying, okay, what is the last point? J is this last point, j is this last point, j is this last point. So for sure, for the next problem, I will just say start from j plus 1. Okay, it's your new problem with the reduced D, because one day I have used and I have separated and given this particular problem to the day 1, or basically all this group of jobs I have allotted to my day 1, and the remaining jobs I'll do for the remaining days, which is starting from j plus 1. Again, j plus 1, which is this point, j plus 1, which is this point, j plus 1, which is this point, j plus 1, this point, j plus 1. Now again, the problem will be, okay, for this I to j, you will have to figure out what's the maximum value, right? Because it is not that, okay, it's decreasing or increasing. It can be up, down. So you have to figure out what can be the maximum value. So one way is you compute it again and again for all. Okay, from I to j, I compute it again and again. So that will take a O of n time. So one partial thing which you can say in the interview is, okay, it is taking O of n time. It might take O of n time. Again, I don't know. I'll tell you. Maybe it is, maybe not. But if you want to compute the range maximum, and I to j you are computing again and again, so you can pre-compute this using the range minimum or range maximum query, which is we do it via sparse table. So you can just watch Erito's video. In that you do it via sparse table, although in this case it is not required, because you will be going on to all the pairs. Which I mean is that if you are starting from this specific I, okay, initially the maximum element from I to j, I to this j, maximum element is 6, I to this j, as you move on to the next j, you are just simply moving on from left, right. Okay, I is here, j is initially here, so maximum element is 6. For the range I to j, I move it, I encountered 5, I'll say 6 or 5, who's the maximum? Okay, still maximum is 6. So from I to j, maximum is still 6. Okay, I move my j, 6, 4. Oh, maximum is still 4. Maximum is still 6. So I to j maximum is still 6. I just move on, 3. But still maximum is still 6. So you saw, as I'm moving my j itself, which I have to move, I'm also able to figure out what is the maximum for this specific range I to j. So this part will not be required for me, but still it will be good if you can tell in the interview that first you thought of, as you saw the range and you have to find the maximum, so you can think of range maximum. And as soon as you speak this, then go back and say, okay, as I'm also moving my j, so I can use this j moving to figure out, okay, as I'm moving on to every element, so meanwhile I am moving, I can figure out what's the maximum for this range. Okay, so you know one thing, that you can figure out what's the maximum for this range, as you keep on moving your j pointer. And the remaining part of the problem will become that find the answer for j plus 1 comma d minus 1, and you started your problem with I comma d itself. So it's nothing but a simple recursion. You started from the I comma d. You will try on for all possible j's. Again, I'm saying all possible. I'm not saying all j's. I'm saying all possible j's. But what is possible meaning? Possible as in you have to make sure that you should try only up till the point such that your remaining portion should actually accommodate remaining d's. Because it was very compulsory that you take one task every day, right? Okay, bhaiya, but okay, it's a simple recursion. What about the repeating subproblems? Like, is it a DP or not? So for that, just a simple example, we can, because in this it is not visible that it's a DP, because we cannot see any repeating subproblem anywhere. But if we increase a D a bit, like earlier my D was 2, I increase my D to 3, then I can say, okay, for the first day I take 6, for the next day I take 5, 4. For the first day I take 6, 5, for the next day I take 4. Both are different cases, but the next problem will be start from the day 3 with the remaining day as just 1. So now the sub problem is same which I have to solve. So I got to know, okay, yeah, it's a recursion. I comma D to try on for all the possible J's, and the next state will be J plus 1 to like J plus 1 comma T minus 1. But it's a recursion also because it has repeating subproblems. So I'll just simply apply DP with memoization. A simple recap of how the code will look like: I comma D, as I showed you, it is the current index which I am at and the number of days which are remaining. The simple base case, as I showed, although if this also, if you don't want to, you can simply have also one more base case. If your D is 0 and your index has reached the end, N is the last, like, because your indexing is 0 to N. If I have reached N, which means I have covered all the indexes, then you can simply return 0, else, which means if the D is 0, then return int max. If the I is N, return int max. These, if you want, you can also write these 3 as the conditions for the base condition instead of this one condition also. Still, both are okay. Again, these 3 condition, as in if both are, which means if my D is 0 and my I is equal to N, which means I have completed my entire array and also I have completed all the days, which means now no days are remaining. It's a valid case. Simply return a 0. Bhaiya, why 0 and why int max here? Because I wanted minimum. You remember, minimum difficulty I wanted, so I return the minimum value if it's a valid case, maximum value when it's an invalid case. And again, if it's a 0 but still I have not reached my index, then return int max. If it's a N and I have not reduced my number of remaining days to 0, then also return a int max. Else, if you don't want to write these 3 conditions, you can write just one condition saying if your day remaining is 1, then get from this index I to up till the very end, get whatsoever is maximum element, and that will be your answer for the last day, itself. That is also you can do as a base case. Again, you can write anything, either this or the 3 conditions I showed you, like this, right? Now a simple memo check which we do for DP, and these simple cases, try on for all the possible J's. Again, coming back, all the possible J's I was referring. Now when I say possible J's, I mean just less than equal to N minus D. Bhaiya, what does N minus D means? N minus D simply means is that if you have your elements as, let's say, 6, 2, 4, 5, 6, indexing as 0, 1, 2, 3, 4, you say, okay, N is 5, which means I have 5 elements. My days, let's say, remaining are 2. So if my remaining days are 2, so I'm saying N minus D is actually 5 minus 2, which is actually 3. So I can go at max up till the N minus D. Yeah, my remaining days are 3. N is 5, D is 3, which means N minus D is actually a 3, which means you can go up till this J index. For sure, you will be having, as you'll see, up till J, which means your J can at max go up till this index, which is index 3 itself. So you have to start in from index 4, which means you still have one element, which is, okay, because currently your D was 2, because you have, as you saw, your D was 2 initially, but in the next future on, you will have to pass D minus 1, which is the remaining days will become actually a 1. But still, it is just showing that, okay, I will have 1 day as remaining. So just to make sure that you are actually also saying, okay, the remaining days which will actually remain should be a valid remaining days, so as to build my valid answer, I am just doing this condition itself. If you still don't want, you can also put a base condition corresponding to this condition in the above, and you can handle that also. But still, we just did this like this so that we always handle that, okay, remaining days, like we only go up to that J such that the remaining days are all equal to the number of days which we are passing on for the J plus 1. Cool. Now it's just that we figure out, as I spoke, that we always figure out my maximum value as I keep on going to all the J indexes, and as I do this, I will update my answer with simply the minimum answer, as you saw, that it's just a trying for all the possibilities, but trying as in after trying, just get the minimum value. That's what you want, right? Answer is the minimum answer of, again, this is the maximum value for the group I to j. It is the maximum value for the group I to j, and go and ask a recursion, or basically simple like DP, to solve for j plus 1 with the reduced number of days, and ultimately simply return the answer. Just do a simple memoization here also, and that is done. Exactly same code. I just firstly have this base condition, his main condition, to just say, okay, if n is less than d, simply return the -1. Here I initialize my DP with simple n and d plus 1, as I also showed previously that my days are actually from 1 till my days d, but my n is indexes, which is actually from 0 to n minus 1. Right, that is how the indexing of an array works, from 0 to n minus 1, but the days are the number, right? My day, let's say I say my day as 5, so it will be 1 2 3 4 5, so 5 I should have a value, so that's the reason it is d plus 1. Initialize with the by default value, which is -1, so as to make sure if it is not -1, then I have a value. Now if we go back and simply go back and call the recursion starting from the index 0 with the remaining days as d, as you saw, okay, remaining days as d, so I should have a d plus 1 to address that. Now I simply call my simple recursion with this simple base case as I showed you. If my d is 1, then starting from the index I up till the very end, go and find what's the maximum value, and that will be your maximum value for that last day. Now if that is not the case, which means okay, base case is not there, simple memoization check, which we do every time. Now a simple recursion, which we simply do, that answer is initialized to int max, maximum value is initially 0. This maximum value I will keep on updating as I go on to every j. So as I am on current j, I'll go, as I showed you, I'll go on to every j starting from index I up till the index n minus d, which means if I have the array, my I is here, so I will go, okay, my j is here, my j is here, so it's just showing, okay, from I to j a sub array I am taking, and then my recursion will solve from j plus 1 with the reduced d number, which is d minus 1. So I'll just do, okay, j plus 1 and d minus 1 as for the next recursion state, and ultimately I will be getting my answer and just pushing that answer in my DP so as to memoize it. Ultimately you will see that as you are going on to I and D, so you will go on to all possible I and D. So I is nothing but n, D is the D itself, I is nothing but indexing for length of n, and also you saw that you are in worst case going on to all the j's. This j also will give you a n, so your time will be O of n into d into n into d is the state, and n is the, for this particular one call for all the possible j's which you are making inside one DP state of O of n into d, and space will be only O of n into d because it's just what you are memoizing. Again, n into d into n, space is O of n into d. So that will be your time capacity. Can you improvise it? Maybe, maybe not, but that you can only think of, as I said, if the interview asks you to memorize or improvise your DP, then you will have to convert that to a bottom up. So for sure, now the interview is saying, can you please optimize it? So what I'll do, I'll simply convert that to a bottom up. How to convert it? As simple as that. If you go back and see what we were doing is, we were having, okay, from I to j, I was having some I to j. From that I to j, I will go and get the answer, okay, I'll go and get the maximum value, then I'll simply call my recursion, okay, from j plus 1 with the reduced d value. That is what I want to find, right? J plus 1 with the reduced d value, okay. So what if I can just pre-compute this? So I'll go on to my previous d, which means currently my d is, let's say my d is 3, so I have to go on to previous d, okay, I'll go on to my previous d, which is d equal to 2, and will compute the answer for the entire array. So what I'll do is, and primarily what I primarily wanted is compute the answer from this j plus 1 to the super end, so which is for this with the specific index up to super end. I want to get the answer for this previous d. So again, recapping, that I to j I wanted the answer, so I can get the answer maximum value for this corresponding d right now, which I have, but then I will ultimately, my recursion was going and calling my answer for j plus 1 with the reduced d value. So it means that for the previous d, which is d equal to, I need to know the entire answer for this entire array. But ultimately right now I am only concerned about the answer from this index, which is this index with the value 2 up to the super end. I wanted the answer. So again, I can go and try for multiple values for this entire state of d. with the reduced d, you saw it is d equal to, and then with this you will try for, let's say, I to j this value. Ultimately it will say, okay, go and ask for reduced d value and starting from this index, which is j plus 1. So again, when it is done, it will go and ask for the reduced value of d with the increased j value. So you can just simply say that your base case will look like, if this entire thing, let's say your d has been done, which means remaining days are 0, and you have reached the super end. As you saw now, you are just going up till, like, you are moving to the end. Okay, you have reached the end, then it's a valid case. As I also showed you in the bottom up also, the if condition I showed you, right? Rather than this if condition, you can also say that if your remaining days are 0 and also your index has reached the end, then also you can simply return a 0. So here in this bottom up case, I can simply write this as my base condition, that my dp of n comma 0 will actually be, which means my remaining days are 0 and also I have reached the super end, it will be actually a 0. Else rest will be int max, or basically a by default high value. And that is what you have to simply do. Simply exactly same. So I'll just simply do one thing, that for all the states of my dp, I will initialize with my int max, and for my 0 comma n, here the 0 is d, which means your remaining d is 0 and it is your index. I'll just say if it's a 0, because it's a valid base case for me, for bottom up and for top down, both of them. Now, as I told you, I'll go on to all the days from the smallest day, and see, this remaining days is the day itself, which I was referring, this day. So, and as you saw that I need, for this day equal to 3, I need to have the answer for day equal to 2 itself, right? So I'll go on from all the smaller days to the higher day, keep on increasing my days, and for all the days, which means from this, let's say, one small day, which means for, let's say, this d equal to 2, I will go and have to compute the values for this entire array. So I'll just go and compute this value for the entire array. Again, this is the exact same condition, right? That you will go and try for all the I indexes, all the possible I indexes which you have, and for, let's say, for this I indexes, you will just go and find the maximum value. This is the entire same condition which we wrote above also, that for the corresponding I index, you will go and try for all the j's, exactly same condition. If you go and remember, for the corresponding current I index, you will go and try for all the possible j's, exactly same. So I just wrote the exact same condition here itself, that for this corresponding I, you are going to try for all the j's itself, and with this j, again, go and update your dp value, because here it is just the value of dp of day remaining, which is this current day which you have, current I which you have. It will be, okay, you have to minimize the value, so keep on minimizing it with what, with the maximum value. Again, maximum value will keep on computing here itself, as you were computing earlier also, and also go and ask for dp of remaining days minus 1 and j plus 1. Remaining days minus 1 you would have always computed, because you are going in the positive direction always, and j plus 1 you will always be computed corresponding to dp of j minus 1, because it is inside this value. It is inside this. You saw now, for the days remaining, which is the previous value, which is minus 1, this entire shit would have been computed. So j plus 1 or any of the index will be available to you. That's the reason you compute it in this order itself, and that will be your entire code change which you have to do. If I go back and look at the code, again, in the end, you know that your answer will be stored in your d, because you have to compute for all the days are taken care of, and starting with the index 0, as you are doing in the top down also, just the exact same thing. Code exactly short and simple. Initialized your dp, initialized with the int max value, just did, okay, my base case condition, put in here. Now went on to all the days remaining, went on to all the corresponding i's for that days, find out the maximum value. When I go on to all my j's, it is the exact same logic which we did, that max value is updated by the max value of current job index, job difficulty of j. Just simply, you saw, bhaiya, this if condition was not in the code which you wrote above, which means not in this handwritten code which you wrote above. Yeah, is the if condition is just to handle the integer overflow, because you saw that this value, it let's say if this is int max, if you add anything, then it will have an integer overflow. So before even like coming into this condition, I will go and simply have a check that this value should not be int max. So as to avoid overflow, if you don't want to write this, simply have a long, or you can also reduce this value according to constraints. That is also okay. It's just a high value which you wanted. Now I just do, okay, simply get this and check this. If it's not equal to int max, so it should not impact this, because you saw it will not give you integer overflow. And that is how you can simply get your answer for the dp of days remaining ni, and ultimately getting your answer of dp of d comma 0. But bhaiya, again in this above you showed that it is simply a dp. Yeah, you also remember now we have a condition that, okay, what if the answer is -1? Yeah, that is simple, that if the answer is int max, then for sure it's a -1, else which is answer is less than int max, so it will be dp of d comma 0. And again with this, time and space is again exactly same. It's just that now we can visualize it back and see that what can be optimized. If we go back and see, then we'll easily look at that, okay, dp of days remaining are actually nothing but getting a call to simply dp of days remaining -1. Previous states of days are not required, although previous states of I will be required because multiple j's are being accessed, but only one state of days remaining is required. So what I can do is, instead of using a 2D dp, here you saw, okay, I am using n and d, both of them. Instead of using this, I can simply do one thing. I can simply go and use this n and remove this d. Instead of this d, I can make simply two arrays, and with that two arrays I can simply get this solved. So what I'll do is simply that I'll make a dp of last, just storing, see this, I'll store as dp of last, and this is my dp of current. That's it. The only change which I am doing right now is storing this as dp of last, so I'm storing this as dp of current. That's it. So I'll make a simple, like, I reduce my size, I just made it only of size n+1. I make my dp of last itself, okay, you saw exactly same. I'll just keep on comparing. I just remove the entire thing. I just made this entire thing itself, everything remains same, int max. So this will go away, this will go away, this will become a dp of last. So okay, dp of last has become n is initialized to 0. Now exact same stuff is just that I initialize my dp of current, right? Because you know that why I initialize it, because I will have to put my dp of current to my dp of last, so that it can be used later on inside the exact, like inside the actual loop. So I just initialize my new dp of current again with the int max values, because I don't want to get it to a minimum value, because I want to minimize it. My answer needs to be minimum. So I just went on exactly same. Here it's just that you saw that here it will be dp of last. So here also it will be dp of last, it will be dp of current, exactly same. Dp of current, dp of last, and then while returning, like while moving on to the next iteration, just assign your dp of last, like assign your dp of current to your dp of last. And that's the only thing. With this you will not be needing all these states for your dates. You will just need one last date and current date. That's it. And ultimately you will be returning your answer from dp of last itself. Bhaiya, why not dp of current? That is what we have already seen also, but you, like, dp of last will always store your value. Dp of last will always store your value, because you will see, okay, when I have the last day, it will still go inside the loop. Then when it will come back, then it will become a d+1 as the remaining days, then it will break out of the loop. So your dp of last will always store the answer. And as simple as that, here also dp of dp of last, I'll just check the same condition, and dp of last here also, dp of last, if it is there, then simply return the answer. And with this, your space has now reduced by d. Now your new space is O of n itself. Now comes the last, which is the monotonic stack way. With this you can reduce your time by n, but this will not be required in an interview. As you can also see, like, again, the entire dp itself is a 45, like the entire dp from the brute force, top down, bottom up, and bottom optimized will entirely take your 1 hour in an interview for sure. So this monotonic stack kind of thing will not come into picture in your interview for sure. But for the folks who are still interested, as I have Leetcode Premium, so I can access all the editorials. It's a premium editorial, but still you can just go through it if you want. Again, you can see it's it's not required for the interview. It's just for the ones who are like curious to know. Again, in the it's pretty big, so you can just pause it video as you want it, but I'll show you the entire tutorial that what it says if you want to still go and figure out that how this things works and what can be done if you want to do monotonic stacks. But it's just a simple concept of monotonic stack, as in ultimately although I wanted to explain, but the video would have gone very long and the people don't want it. People just like watching short videos. I don't know why. Even if I just tell only the approach which is top down, people will still just want that approach. I don't know. I have seen many YouTube channels making the same and they are getting more views, more likes, which makes me feel that okay, I should also tell only the one approach. But I usually still go on to all the approaches because that is what the interviewer is looking for. It's not that okay, just completing a video or just giving the video in just half an hour or 1 hour and just saying okay, it's just one approach, because top down is very easy, like in half an hour you can get that approach. But going on to all the approaches with the correct, because again, if you go back and see, the code is modification of the existing code. It is not a new code written on top of it. So you have to also make sure that your code which you are writing should be a modification itself, and like not just any code, like a new code, because you cannot write a new code whatsoever in the entire interview. Again, as you can see, it's a very big thing for monotonic stack, but I'll give you a quick crux what it says. It just says that you can just place or arrange your actual numbers, which is the job difficulty array which you have. You can place that and say and keep that in the decreasing order. In the stack, you will keep that in the decreasing order itself, and that is where your monotonic stack will come in picture, because you are keeping that in the decreasing order of elements. So that is the reason we can actually implement that using a monotonic stack, and with that we can actually get the time and space reduced. The code for you, I'll just simply paste that code on the right side so that you have a better glimpse of the code. Java, and again that's the code for you. If I just go and see, so yeah, it's the code. Again, you can just go and pause it. It's just that I'm just showing you just because it's a premium thing, and I don't want that. If we have premium, then why not utilize it for you guys? So it's just that I'm just showing you that okay, if the folks who are concerned or who have a way too much curiosity, because our YouTube channel or basically our group which we have are mostly the ones who want to know everything, right? Because why would you actually even watch our videos? Because you would have watched others videos, right? Then okay, yeah, that's pretty much it. Cool. So go, if you want to check out, you can go and check out. Cool. Bye bye. Thank you. Goodbye. Bye bye. What was that? But yeah, it is.